Alright, another draft physics video presentation. Yeah, well. So look, it's just one person. He did respond. A whole bunch of pointless, in a sense, typing. Or going over the same deja vu arguments again and again. Blah, blah, blah. And it's just disappointing that they won't stay on the subject. They won't answer the pointed questions. Even the question itself is requesting, is there evidence? And they can't just say, no, there really isn't. We just believe it. I mean, they can't just give the honest answer. We just believe. We don't need to see it. We don't need to know it's true. We just believe it. And that's the simple truth here. And they won't say it. And they'll pretend there's no controversy. And they'll establish premises that are just completely undemonstrated by any evidence. So, anyway, so this is the guy who says, if I use the same mechanical mechanism, my arm, to throw two bowling balls, one weighs 16 pounds and one weighs 8 pounds. His premise is that I can't throw the 8-pound ball twice as fast unless I provide it with more energy. So he's basically saying the same energy, the same mechanical force, does not produce the same momentum. That if I push on a light thing, I give it more momentum by some kind of rule. It's just more momentum. So it's a completely challengeable premise. I'm certain at least half the physicists would say, no, that's not true. At least half. And then they pretend there's no controversy. I mean, you just, where could you go with this? All right, so just for the sake of continuity, I won't read the posts I've already read in the previous video. And this will go on for a long time, and there's lots of points in here, and all of them are the same kind of redundant ones, and I'll kind of point that out. So anyway, just as a premise, so this is his statement. An 8-pound ball moving squared 2, which I don't even know what that means, are about 1.4 times faster than the 16-pound ball. So again, asserting that somehow if I do use the same spring to shoot them both, the 16-pound and the 8-pound, that somehow the 8-pound ball won't go twice as fast. I mean, on its face, it's kind of a silly premise. It's just not true. Okay? And, so, and then he will claim, we'll wait till we get to it. So, I probably did read this already, but this is what I typed. I'm seeking real physical experimental evidence of any claim made in defense of the kinetic energy theorem. So I'm looking for real physical experimental evidence. Okay, you claim that the same physical force can produce different momentums. And that's clearly what he's saying. I mean, clearly he's saying if the 8-pound ball doesn't leave at twice the speed, it clearly has less momentum. So clearly the same amount of force has not produced the same amount of momentum. Can you provide any physical experimental evidence? I can provide countless videos where highly prestigious scientists say exactly the opposite. So I linked to the Professor Lewin air track simple experiment demonstrating that the same energy goes this way that goes that way, and it happens no matter what weights I put on either side. Okay. So then he says, that's not what I claimed at all. I mean, he clearly claims it. Okay. What I actually claimed is that doing the same work on two balls of different masses leaves them with the same kinetic energy but different speeds. If they have different speeds, they have different momentum. I mean, you can't play the game. You're saying the different speed is proportionally uneven to the speed necessary to have the same momentum. You're saying they leave with different momentums. There's no other thing you could possibly be saying here. The difference in the speed is a difference from what you would expect, which is twice the speed, and it's that simple. So this is where just the bullshit starts. All right, kinetic energy and momentum are not the same things. Well, obviously the whole argument is about the fact that they're fundamentally different things. That's right. and they're answering the same question, and they're giving you different answers for the same question, which is a problem scientifically. And it's been a problem for 350 years, and you're just pretending it's not a problem. And I'm just saying anybody logical is going to want to know the real answer. There's one that's right and one that's wrong. You can't keep pretending. If I go into space and I use one theory to decide how much thrust to shoot out, and I use the other theory to decide how much thrust to shoot out of my rockets, I'm going to get two different answers. Now, there's no frickin' possible way that those two different answers can both be right. I'm not going to land safely using one of them. That's a certainty. And you're saying the kinetic energy formula is correct when everything about this whole controversy goes all the way back to Newton, and the fact that Newton wouldn't be able to predict where everything would go in the universe. He wouldn't have been able to predict Halley Comet's return if his mechanics was wrong. All right, kinetic energy is affected exponentially by velocity, while momentum changes linearly. So get this just more gibberish about how somehow kinetic energy and momentum aren't exactly the same, describing exactly the same thing, which is, literally motion in a direction. One of them isn't a scalar, and one of them isn't a vector, and one of them isn't all this bullshit. It's quite obviously they're both describing the same thing about what happens to the bowling ball. I mean, damn it. Anyway, classical theory indicates, so I jumped on that crap, that force times time equals change in linear momentum, and momentum equals mass times velocity. So again, just reasserting nothing, saying absolutely nothing. That's classical gibberish, is what that is. It either is velocity squared or it isn't velocity squared. You can't have it both ways. It's fundamentally nonsensical. There is no such thing as momentum is some sort of different thing than energy. Okay, so let's assume we apply Bn of force for 1 second to a bowling ball weighing 8 kilograms and a bowling ball weighing 16, solving for the change in velocity. So again, all of this complex nonsense to attempt to rationalize this silly notion that you can give different momentums when you can't give things different momentums. Alright, anyway, so I don't know if it's worth reading all this. The ball will experience 1 meter per second change in velocity, and the 16 ball will experience 0.5 meters per second change in velocity. So now he's just basically said the change in velocity is exactly half, and he said just in the other post 1.4. I don't know. Yet the change in momentum are still equal to each other. They can't be. So just a minute ago, didn't he just say it's 1.4? Now the change, you can just see it. 8 kilograms going 1 meter per second, 16 kilograms going 0.5 meters per second. So now they have the same velocity again. The proportionally correct velocities. The 8-pound ball is going twice as fast as the 16-pound ball. And yet, when they hit the alley, somehow they're not doing that. The 8-pound ball is now doing 1.4. Can you see this is so duplicitous? They've convoluted their reactions, and they're just making shit up to defend religious dogma. And there's no science here. There's no willingness to accept that these are real questions that need real answers, not this duplicitous. This is just overtly duplicitous. To say in one comment it's going 1.4 times as fast, that is not 1 second, it's only 1.4. It's a doubling. It's not a true doubling of the velocity. And then right here to sit there and point out that somehow, no, it's exactly 1/2 the speed. It's overtly duplicitous. Anyway, once again, we find ourselves in a situation where our desired quantities actually are equal. So again, they can't be equal. You can't say the acceleration was exactly in line with momentum, in the sense that it's exactly twice the speed in acceleration, and somehow when it leaves my hand, it's not twice the speed anymore. How can that make any sense to anyone who gives a crap about any kind of continuity or sensibility to science? That's voodoo. Okay. but the velocity necessary to achieve equal quantities differs. And you said by 1.4, and now you say, no, it's exactly double. You know, whatever. It's true for momentum, just like it's true for kinetic energy, like showed in my answer. You didn't show anything in your answer, so let's understand. I showed nothing. Okay, now then, experimental was it? Yes, experimental data was it? Yes, that's what I'm after. Table 3 in the study isn't perfect, but by looking at the data for bullets fired with similar muzzle energies, so here we go, muzzle energy. All right, you can see that, I mean, it's a charge of black powder. Anyway, generally higher muzzle mass bullets travel slower than less mass bullets fired with comparable muzzle energies. So where in any of this conversation is that could that possibly be relevant? Of course, heavier bullets go slower. The 16-pound ball goes slower than the 8-pound ball. Where did I demonstrate any need to have that explained? Oh, that's right, I didn't. Okay, this experiment did a good job of demonstrating how momentum is conserved even when transferred from a smaller mass moving fast to a heavier mass which then moves more slowly. So the joke is, this is the cart experiment I already linked to. And instead of showing the actual experiment as I did, this is just a description of. So, I mean, more duplicity, right? I mean, can you get any more just plainly duplicitous than to sit there and send the exact experiment, okay, and pretend it's on your side? When, no, it's a demonstration of conservation of momentum. It's not a demonstration of any kind of, it says impulse energy. It says lots of words, but this has, again, this doesn't demonstrate at all. Okay, it is not on his side. The piece of evidence is on my side. So this is more of the dodges. This is like the Pyrrho crap. Just shove, force the person to go look at crap that has absolutely nothing to do with proving your point. You'll just assert. Ugh, this is just pathetic. Anyway. All right. So I respond. The same kinetic energy but different speeds. You can't have it both ways. If they have the same kinetic energy, they have to have different momentums. Okay. You are claiming that equal and opposite force laws are incorrect. So I'm basically forcing him to say, there is no such thing as equal and opposite force law, because you're basically saying that somehow I can, apply a force and it doesn't actualize. That somehow the force just disappears. The 8-pound ball only goes 1.4. Even though I accelerated it clearly at twice the velocity, it somehow leaves at 1.4. All right, I post again the link to, the Lewin thing. Kinetic energy and momentum are not the same things. Fact is, they are direct contradictions. So, so he's sitting there telling me kinetic energy and momentum are not the same things, when that's exactly the point I'm trying to make to you. That they're not in any way compatible. They're not same. They're not neutral. They're not. You can't pretend they're not answers to exactly the same question, and they're different answers. So these people, again, these are scientists, right? These are people who are, supposed to, understand what contradiction is and how it's a really bad thing, and, how you're supposed to do this logic thing, and the logic requires all this kind of compatibility. And they're sitting here in just complete denial of the fact that they have two different ways to answer the same question, and the answers are not the same. Okay, fact is, they are direct contradiction or completely incompatible. One or the other is the truth. They both can't have truth value. So he didn't respond to any of this, of course. Classical theory indicates, so that's his quote. This is, MV started with Descartes. VMV was invented in 1660 as an opposition to Newton's physics. That's the clear history. So this word classical, what the hell can it possibly mean? There's only about a 40-year difference between these two, Newton's momentum, or Descartes' momentum notion, whatever they call it, quality of motion, and this perverse nonsense invented by Leibniz. That's it. So how can you call one classical and the other something else? It's just ridiculous. Okay, both theories are over 350 years old. This word classical just confuses things. But they're going to keep doing it. They're going to keep using it like it means something to somebody. Everybody's supposed to know what classical means when it doesn't mean a goddamn thing. They use it in any way they want to, depending on what the hell they're talking about. It's just such another piece of deception. Okay, 8n of force for the second. So the collision experiments have nothing to do with constant force gravity experiments. So that's, one of the arguments. We can measure final velocity, and the only thing changing in the experiment is the velocity. The bowler imposes a force. The force will be in the form of a speed of his arm's movement. So he just pointed out how the speed of the arm's movement was double, right? And then he says, but somehow the ball leaves at 1.4. Okay, that speed will be transferred to the ball. If you can show me an 8-pound ball leaving at less than twice the velocity, this argument will end with my apologies. So show me the same bowler using the same motional energy, failing to get the 8-pound ball to go twice as fast. Show me that, and this argument is over. Okay, but until I see physical evidence, I argue there's no good reason to believe any of this kinetic energy stuff. It was a nonsense 350 years ago, and it remains just a mushy claim. Okay. Just like it was true for kinetic energy, like I showed in my answers. And I said, you showed no physical experiment demonstrating any change in momentum or conservation of kinetic energy. Okay, so he didn't show that momentum is different, and he certainly didn't show that he in any way collected this extra or less than energy. So there's just no evidence provided at all. Okay. You can see that generally higher mass bullets travel slower than lower mass bullets, blah, blah, blah. Exactly as momentum would predict. You need to collect the end product of total heat generated to do a scientific ballistics test. So again, these are scientists. They're supposed to be able to figure this out. I shouldn't have to. I showed you the cornstarch video, right? Where you punch the cornstarch with high, you go into it with a high velocity and it freezes essentially, it solidifies. So it provides great resistance to high velocity. And then I've made the argument that clay does the opposite. Clay, if you go in fast, it creates lots of energy. It sort of liquefies the clay, and the clay just basically says, go ahead, go through me, I don't care. It breaks down with velocity. Its structure does exactly the opposite of the cornstarch. So we know that there's different ways to measure. You can use different measuring tools, and that these measuring tools aren't something we can build in the lab. We can't make a ruler and put nice little marks on it that are all even. Okay, it's a little more complicated than that when we're collecting the energy. So science should know, oh yeah, well, we have to be really careful about how we collect the energy. And so here he's going to sit there and try to use ballistics tests. One of the hardest things to measure is, the difference in the penetration of a bullet. The difference in the energy is going to be based on, what am I catching the bullet with? How am I applying the friction, the stopping force to the bullet to discern what the energy is? And clearly the stopping forces are variable. So you have to make a pretty, you have to be a little bit clinical and careful and thoughtful in how you design any experiment to collect high velocity impacts and say, yes, I've measured its actual, the ruler is perfect. And they just don't care. That argument is irrelevant to these scientists. Okay, so, and that's, again, there's obviously, this is just a desperate effort to say we didn't make a mistake 350 years ago, and we're still not making a mistake, and it's still good science, and it really does happen, blah, 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 even though the evidence indicates it's really, really bad science. The history indicates really, really bad science, okay? No scrutiny, no unbiased argumentation, clearly agenda-motivated people. Really, every bad element you could have in a science event was there. This is a cartoon of science. Anyway. Okay, as you can see, generally, that generally higher mass bullets travel slower. We already did that. Exactly as momentum would predict. Yeah, so I said, so you need, yes. So if you're going to really test for the energy of a bullet, then the way to do it is to shoot it into water and measure how much the water heated up. That'll tell you how much energy the bullet had. Okay, this experiment did a good job demonstrating how momentum is conserved even when transferred from a smaller mass moving as fast to a heavier mass which then moves more slowly. So this is the classic train, right, that clearly proves the conservation of momentum. It has nothing to do with proving kinetic energy. So the train's moving 10 miles an hour, you drop a double weight on top of it, and now it moves half the speed away. Clearly pointing out that momentum's the right answer, clearly pointing all of that stuff out. He's claiming because we say the train has, they're saying that the train lost half of its momentum, its energy, when I made it heavier. So it's by just dropping the weight on it, somehow half the energy disappeared. That somehow I heated the train, all of this kind of horseshit. And we know we can drop that weight very carefully and very lightly and do very little to cause any extra friction. There'll be a tiny bit more weight on the wheels when it hits, but if we drop it on a flat car, and it's just millimeters above the flat car when it goes by, and we just drop the weight, it'll be meaningless, okay, in terms of how much energy is lost to friction. But they say it loses half its energy. Now momentum says no, nothing changed. It's got the same momentum. Yes, it's moving slower because it's much more massive, but it's got exactly the same energy. Now, it's a classic, simple experiment. You can't get much more, like, let's bring it all the way down to a 10-year-old. 10-year-old could grasp this concept, right? I might as well draw it because, these are the important experiments they ignore. He's trying to use it as an argument in defense of his nonsense. And they're saying, how can you possibly convert this experiment into something plus for your side? You're just, how can they do this crap where they pretend the experiment is validating their nonsense, right? It's again, it's just duplicity. All right, so you just have a train. Let's do it's a flat train and it's moving, okay? You gave it velocity. It's moving 10 miles an hour, okay? All right, down the track. And you drop a weight that doubles the mass. So the mass is, this is one mass, and this is one mass. And so now it's going to be a two-mass train leaving. Okay, so now it's going to have two masses. All right, and it's that simple. So, and their theory is, well, this two-mass train is going to go 5 miles an hour. Okay. And this one was going 10 miles an hour, and all you did was drop this. And like I say, if you drop it just such a tiny amount of distance, it can't possibly cause much disturbance. And so that's all you've done. You just have two different trains. You have this train going 10 miles an hour, that's with one mass, and you have the two mass going 5 miles an hour. So it's almost like you could just isolate those two trains. Their theory says this train has twice as much. No, this train over here, okay, has twice as much energy. That somehow you'll do twice as much work. And it's not true. If I turn this into giant snowballs or something, that it matters how heavy it is. That the energy you're going to have to use to push, roll something that's twice as heavy is going to be more energy, and it's going to end up being twice as much energy. Mass works, momentum works, MV works. It gives you a correct impression of the energy involved. How can any real good scientist tell me? This guy's he's in school for electrical engineering. How can he possibly believe that if I put a generator on these two cars, I'm not going to generate exactly the same amount of energy? That yes, this one's going slower, but it has more capacity to keep going, keep turning the generator. This will turn it faster, but this will turn it longer. Just a simple truth. And I'll get the same amount of watts, whatever, 1,000 watts. I'll get the same energy out of this that I'll get out of this. How can that be denied by physicists? How can a physicist, a fucking person who's gone through years, maybe 6 years of physics education, how can they sit there and believe that this one just magically has twice as much energy, and this magically lost half of its energy, okay, through some magic? It deformed. It fell off the track. No, it didn't do any such thing. So, I'm just saying, so he's using this example, to sit there and defend this stupid theory, when this example perfectly shows how the theory is nonsense, absolute nonsense. So he's just making this dogmatic declaration. This one has half as much energy. I dogmatically, authoritatively tell you so. I will never demonstrate it. I will not crash these two objects into a spring, right? Because we know if you crash these two objects into a spring, they will compress it exactly the same amount, okay? Demonstrating they have exactly the same amount of capacity to move things. The same capacity, the same force. So, here he is using this paradox, this experiment that shows the paradox. It shows it right in your face. It rubs it right in your face. And he's using this experiment to say, look, I proved it to you, didn't I? Oh, fuck. It's just too fucking dishonest. You'd like to just cut these people a break and say fine, but this is just so dishonest. Okay. All right. You showed no physical experiment demonstrating any change in momentum, so we did that. All right, you can see that generally higher mass bullets, we already did that. Okay. All right, so then he said this experiment. Then, okay, and I said the experiment clearly shows conservation of momentum and clearly illustrates the paradox kinetic energy creates by stating the heavier objects somehow lost one half its energy, when in fact if they crash the carts into the same spring, it will show they have exactly the same momentum / energy. So he won't deal. I blew up his silly argument. I've called it a paradox, and there won't be anything. He won't go back to the subject. All right. So there's somewhere in here I did thank him for typing all this stuff. Yeah, I appreciate your continued response. So as much as this is garbage, but I do appreciate at least he stayed in the conversation, attempting to explain. But again, on hindsight, looking at how deceptive all this is, this is just the same dodge. Force me to go, jump to your silly pieces of nonsense and call them evidence, when they're evidence for exactly the opposite argument. Okay. So then he writes, in collisions, total energy is conserved, not kinetic energy. So now he's saying kinetic energy is conserved, which is another way of saying, once again, that I can destroy momentum. Well, no, he's saying not kinetic energy. So this time, now he's saying momentum is conserved and kinetic energy isn't. So before he changed the speed of the 8-pound bowling ball, okay, to make the kinetic energy formula have conservation. Now he's saying exactly the opposite. You see, they just keep wishy-washy. They keep just going either way, whatever way they want to go, to try to rationalize something that can't be rationalized. The simple truth is the two theories give different answers, and they are not in any way compatible in physics. They can't both be right or sensible or appropriate or useful or any of that crap. Okay, there is no conservation of kinetic energy law. So again, so he's arguing with me. I'm the one saying there's conservation of momentum. I'm saying kinetic energy doesn't even exist. It's mush. It's baby talk. It's silly. So of course there's no law conserving something that doesn't exist. All right, for collisions or otherwise. In collisions, energy is lost to friction heat. So the catch is, right, is that heat is just like knocking pins down. It's all pin knocking down. So heat are pins we can't see, but that's all it is. It's just using up the momentum. So you can't do both, though. You can't heat something and then knock down pins. You have to do it the other way around. You have to hit the pin and then have the pin heat something. So you have to do it in the right order. Okay. But everything sort of ends in heat collapse. Okay, and distortion of material. So we got the same bullshit terms like physics girl. Oh, yeah, the train lost all of its energy to heat and deformation. Yes, it just all went away. Heat and but they won't show you anything deformed, and they won't show you anything heated. Okay, in situations where kinetic energy is the only form of energy an object has, I jumped on that, and no energy transfer occurs otherwise, whatever the hell that could possibly mean. So somehow he's saying in situations where there's only kinetic energy and no momentum, we can't do that. Okay, then the velocity obtained from energy calculations will equal the velocity obtained from momentum calculations. Yes, there are twice a day your silly formula can be correct. Okay, like a broken clock, twice a day it can be correct. But all the rest of the time it's wrong. Okay, momentum and kinetic energy describe different things. So I'm sure I asked, like what? How can they be different? Different how? Okay, they are not in contradiction. They simply are distinct. Distinctly what? I mean, there's only the energy. There's not energy or benergy or zenergy. I mean, what else is there? There's energy. You can't sit there and say, oh, there's some other kind of energy, like energy 1 versus energy 2. What are you talking about? They have to be describing the same thing. Okay, momentum is the resistance of an object to change in motion, which again doesn't mean anything. There's no such thing as resistance, okay? I mean, this is another argument that could be made. So physicists keep saying that things are resisting, like somehow this sponge is resisting moving. No, it's saying, give me a force and I'll move. Okay, it's not resisting. It's not saying, I won't move. I'm not going to move. It's not saying any of that shit. Okay, nothing resists moving. You have to give it reason to move. You just pour the force in and it goes. I mean, come on. So they just make up this gibberish years ago, and they just keep reciting the gibberish. The Holy Ghost said, flop, flop, blah, 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 tie your shoes, left foot first, blah, 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 blah. I mean, it's just religious goop. All right. All right, so momentum is the resistance of an object to change its motion, and kinetic energy is the measure of the energy it takes to bring an object to a certain state of motion. So again, they're both descriptions of what energy is, okay? It's moving from one object to another object. My arm moves, the bowling ball now moves. The bowling ball leaves, okay, it has what I gave it, motion. All right, then it takes the motion and it moves the pins. I mean, come on. This is just such bullshit, nonsense rhetoric. Let's see. Bring an object to a certain state of motion. They are related quantities, but not identical. So this doesn't make any sense. I mean, they're related how? They're both descriptions of energy. Yes, they're clearly not identical because they give completely different answers to the same question. And don't have to be. So again, there's the wacky theory. 2 plus 2 equals 4. 2 plus 2 equals 2. They're both right answers. How can they both be right answers? I mean, this is ridiculously stupid. Okay. It's really not that difficult to understand. Well, of course, it's impossible to understand unless you read the history and you realize the whole thing is made up, okay? I mean, Newton's worst enemy wanted to defeat Newton, so he just made up some fake physics to defeat him with, and somehow all the silly people fell for it because they painted it the right color. MV squared! You know, they have a party for it, and they presented it like in a movie theater. And so everybody, MV squared, holy shit, that's amazing. You know, they fell for a complete pile of shit that had no evidence backing it up. No physical evidence supporting it. Just a completely silly idea like, well, light things go farther in gravity, therefore they have more energy. When any idiot can know they don't have more energy, light things go through gravity because less gravity hits them. Duh. Because they have less mass. Duh. You know. But that's what this is all made out of. That's how bad this is. I mean, this isn't just a little bit of a farce. This is a huge, gigantic, stinking farce. Alright, anyway. But identical, but don't have to be. So again, just this complete denial that there's any problem here. And clearly it creates paradoxes and it gives wrong answers. But let's just pretend it's all okay. Alright, it's really not that difficult to understand. If you exert the same impulse, force times time. Yes, the same force. The force is a total amount of force. It'll cause something to do a total amount of something. It really doesn't matter, this whole, times time nonsense. It's not going to have anything to do with it. I mean, it obviously has something to do with it in terms of the spring has to move, but obviously the spring will move faster for the light object and slower for the heavier object. It does it automatically. Alright, on two objects with different masses, then they will have different kinetic energies. So they keep just saying the same shit over and over and over. So even though they have exactly the same momentum, they somehow have different magical energy. So you've used the same force, you've given them the same momentum, and somehow they have different energies. And I have to explain to physicists how that sentence doesn't make any sense. I mean, I really have to sit here and keep doing this over and over and over again. Endure all these slings and arrows for a sentence that you have to know can't make any sense. I use the same force. I give them the same momentum. Yet they have different energies. I mean, you really believe this horse shit? Okay. If you exert the same amount of work, change in energy, on the two objects with different masses, they will achieve different momentums. No, they won't. So now he just says exactly the opposite. So you see this duplicity here. No, if you apply the same energy to two objects, they will achieve different velocities and therefore will have the same momentum. And he just said it again. They'll have a different momentum. So he doesn't believe in conservation of force or momentum. This is because kinetic energy changes exponentially with respect to velocity, while momentum changes linearly. He already said this, right? We already read that, didn't we? Okay. All right. So I mean, he's saying the same shit over again, and it's just, 1 minute momentum's conserved, the next minute, no, I'll just break it. All right. Your inability to understand this is what's causing your confusion. Yeah, fuck you. If you roll an 8-pound ball and it achieves twice the speed of a bowling ball, I guess he means a 16-pound ball, then they will conserve momentum but have different kinetic energies. So he just said it again. So before he says they didn't conserve momentum because he said the 8-pound ball goes 1.4, right? I don't have to take you back to the post where it says 1.4, right? The 8-pound ball only goes 1.4. Now he's saying the 8-pound ball does go twice as fast. So the 8-pound ball goes twice as fast because momentum is conserved. But somehow the bowling balls have different energies. The 8-pound ball has twice as much energy. So he's right. So we're right back to the start of the whole fucking thing, and and he's just basically saying, yes, that's a paradox. I mean, he should just say right after this, and yes, that's paradoxical nonsense. Yes, I understand what I just wrote is paradoxical nonsense. Can't possibly be true. No hope that it's true. Alright, you clearly didn't look at table 3 in the source close enough, by the way. It reveals some very interesting experimental insights. No, it doesn't. It doesn't verify anything because, frankly, this isn't a very clinical scientific test. But regardless, The momentum of the 38 caliber ammo is 2.4 times that of the 22 LR. So we're not even getting the weight of the bullet, right? That's all that matters here is the mass, right? We don't care about calibers and all this kind of crap. It's a velocity and mass equation for both of us. So he's not even using mass and velocity. So anyway, I'm just going to skip all the ballistics crap. And I point out, let's just stick to a world where we actually can capture the energy with some kind of reasonable expectations. Let's not do experiments at the speed of sound. There's lots of other stuff we can throw. We don't need to throw bullets. All right. So I just posted this because it was strange. Reply to your comment, answer to, is making a PSA ball, energy ball possible. So this other asshole, some douchebag who actually has an account at Quora for a year and never answered a question and never posted a question, did post a response to this. And then he somehow is able to change the subject of the query. So my question was eliminated and replaced with, is making a PSI ball, energy ball possible? So the question I asked was replaced with this stupid title. So even if somebody wanted to reply, they wouldn't see it as the right title. And even if they actually posted the question where somebody could see it, which they don't do either. So anyway, that was really retarded. So I appreciate your continued response. Just curious, but why do you let users change the question being asked? I mean, it's just so bizarre that they just let some user who has no status, I mean, it wasn't like he was a moderator, just decide to change put the question as a sub-question to some other dopey question. I mean, what the fuck? And there's no way to fix it. You're just like, what the fuck? Why did you let this asshole fuck this up? I asked a question. I didn't ask that silly question. Why are you putting my question? Why are you disguising my question as that stupid piece of shit? So anyway, just the same chicanery, the same bullshit. I mean, God, the world just runs on, let the trolls control everything. Yeah, it's disgusting. In collisions, total energy is conserved, not kinetic energy. So that's what he said. This breakdown in communication starts with the word energy. Like Newton, I claim all energy is momentum, and it can be traced through any interaction. The big objects aren't moving, then the little bits are. Now, the irony is Leibniz said the same thing. So Leibniz understood, they were starting to understand the concept of heat. Okay, so they were starting to understand the connection between heat and momentum. And that, if you're watching the energy get destroyed, it really didn't get destroyed. So both Newton and Leibniz understood, if the clay things smash into each other, they both understood that the motion this way has been converted into motion this way and that way and in lots of other ways. That the stuff inside is now moving. And that's where the energy went. Okay, anyway. Where was I? Okay. In collisions, total energy is conserved, not kinetic. They break down and communicate. Okay, starts with the word energy. Okay. Momentum and is traced. Right. Okay. Yes, so I already did all that. All right. There is no conservation of kinetic energy law for collisions or otherwise. So he's telling me there's no conservation of kinetic energy, when, of course, I don't think you can conserve something that doesn't exist. So I said I would counter, you can't conserve what doesn't exist. Okay. In collisions, energy is lost to friction, heat, and distortion of material. So that's the classic bullshit, out. So physics girl does the simple experiment, the train changing size, changing masses, and basically says half the energy just disappeared as some sort of deformation and heat. Yet there's no example of where all that would be, because it didn't. It really has the same momentum. She's conceding the train successfully has exactly the same momentum, and yet she's saying somehow it lost half the energy. How could you have the same momentum and have lost any energy? I mean, it just does. You can understand how it can't make any sense. It's like saying I knocked down all the pins with the bowling ball stopped moving, okay, and yet I still have some energy. How can I still have energy if I used it? I can't use it twice. Like I said, you can use it twice if you understand that you can use the bowling ball to hit the pin and have the pin turn it into heat. But you can't turn it into heat and then knock the pin down with the heat. That's not going to happen. Okay. To greater or lesser extent only, in a Newton's cradle, for example, very little energy is lost to heat in each impact. But over time, I didn't write this very well, most interactions will end in heat. Well, the important part is that it ends in heat. So in the Newton's cradle, each time the balls hit, they do create a tremendous amount of heat at the impact. But it's a little tiny impact, so, a little bit of heat. But each time it's losing some energy to heat. So over time, bang, 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 eventually it dies down because all the energy has been used heating the atmosphere, essentially. So even if you made a perfect swivel for them to swing on, even if you took away the air resistance, the heat created by the two balls hitting each other each time would still use up all the energy eventually. But you can't use it twice. Okay. In situations where kinetic energy is the only form of energy an object has. Okay, so that's when I said, could you describe such a situation where there is kinetic energy and no momentum? And I didn't get any answer to that. Okay, and no energy transfer occurs otherwise than the velocity obtained from energy calculations will equal the velocity obtained from momentum calculations. So clearly they don't agree at all. So this is again just some sort of nonsense that somehow the two formulas are compatible, when no, they're saying the thing has, one thing says it has twice as much energy as the other's formula. They're completely in contradiction. They keep trying to say it's not a contradiction. Of course it's a contradiction. All right, this reliance on suspect calculations is another detriment to constructive conceptualization. Your theory says 5-ton train, so now I give the train example, and he just doesn't, he's totally unresponsive. 5-ton train going 10 miles an hour has twice as much energy, ability to work as a 10-ton train going 5 miles an hour. I claim you will never prove that to be true, and that if you actually collected the energy of the moving objects in a scientifically sensible manner, it will be clearly demonstrated that they have the same capacity to do work. This is what I would like to argue. So I'm just pointing, this is the argument. I can form it this way. I can form it as two trains banging into each other. I can form it in different forms, just shooting objects up into gravity. I can change the experiment into different forms. 2 bowlers, 16-pound ball, 8-pound ball. I can do it in all these different ways, and none of it's getting resolved. I mean, none of you will stay on the subject and explain. And when you do explain, you come up with complete crap, right? So you said the 8-pound ball goes slower. And yet, your mathematics, you conceded, no, the acceleration is twice as fast. So somehow my arm accelerated twice as fast, but somehow the ball left 1.4. I mean, you can't see how dishonest this all is. All right, momentum and kinetic energy describe different things. That's not the history of the two formulations. The kinetic energy formula was proposed to replace momentum. Clearly that's the history. Clearly that's what Leibniz was arguing. Clearly that's what the French woman was arguing. Clearly. It's to replace momentum. Momentum's wrong. mv squared is right. Okay? Newton's dead force is dead. The living force is the real force. Can't be clearer history, and yet they just keep saying it. Keep pretending this isn't about, there's no controversy here. There's no problem. This is perfectly sensible. To have two different answers for the same question, brilliant. Okay, as an overt attack against Newton's physics. So no response to that point either. They are not in contradiction. They simply are distinct. So just more nonsense. Momentum says the 10-ton train has just as much energy as the 5-ton train. In direct contradiction, the kinetic energy theory says one of the trains has twice as much energy as the other. I mean, you can't make it any clearer. How is this not a contradiction? Momentum says that it's equal. Kinetic energy theory says it's dramatically different, twice as much energy. How can those not be in contradiction? Yeah, I mean, it's just amazing. But, it's just denial. Momentum is the resistance of an object to change in motion. So that's his silly, whatever definition. Newton and Descartes considered momentum energy. No one has provided me any evidence they were wrong. Okay, so there's no evidence momentum fails in the first place, and there's certainly no evidence that Newton didn't do mv, that he didn't take the mass number in kilograms and the velocity number in meters per second and calculate, a strength of a force. And that's exactly how he did it. So let's not pretend he was saying it was something else. He knew it was energy. He knew the product was some new thing you called its momentum, its energy. The kinetic energy is a measure of energy it takes to bring an object to a certain state of motion. Where did you get this definition? Just about every physicist I've heard defines kinetic energy as the ability to do work. So they're just changing the, 1 minute energy is how much work did it take to move you. The next minute it's how much energy did it take to stop you from moving. And it's all just gibberish. But it all comes down to how far did you travel in the gravity? No, you don't do gravity experiments to tell you how much energy something has. You don't throw things in gravity and say the light that because the light things go further, that means they have more energy. That's how dumb this really is. I mean, that you could explain to a 10-year-old, right? That light things go further in gravity, but when they land, they have a certain impact. Light things go bleh, and heavy things go bang, right? So light thing goes bleh. Heavy thing, bang! So clearly there's something not quite connected between the light thing going higher and it going pih, and the heavy thing going less high and it going bang. And physicists can't figure this out? That maybe gravity isn't a very good ruler for measuring how much energy something has? Like saying how far it went in the gravity would be a really dumb way to approximate energy. Yeah, it would be really dumb. Alright, anyway. Alright, kinetic energy to measure the energy. Okay, where did you get this definition? Alright, they are related quantities. They are related as 2 plus 2 equals 4 and 2 plus 2 equals 8. So I'm just pointing out there's no relationship. There's one that's a right answer and one that's a wrong answer. You have to pick one and you have to attempt to destroy the other. You have to point out how the other one's nonsense. I think it's easy to point out how the mv squared is nonsense. It's just silly. mv, there's no reason the velocity is twice as important as when it comes to anything's energy. It would just be ridiculous to think so. The mass and the velocity are equally important. Okay, but not identical and don't have to be. They are conflicting answers to the same question, I point out. It's really not that difficult to understand, yet it's impossible to find any credible physical evidence. So it's not hard to understand, but somehow it's impossible to find any real physical evidence. If you exert the same impulse force times on two objects with different masses, they will have different kinetic energies. This is the experiment I would like to see. Show me the experiment where they collect these different energies. So I'm just saying, put the generators on the trains. Show me, bang the trains into a spring. Do something to show me that this heavy train going slower has 1/2 the energy of the light train going faster. Show me. Is that asking physics too much? Oh man, it's just so bad. If you exert the same amount of work, change in energy on two objects with different masses, they will achieve different momentum. So now he just says there is no conservation of momentum. Right? He had said, does all this crap, if you exert the same amount of work, change in energy, on two objects with different masses, they will achieve different momentums. just isn't true. The same force always produces the same momentum. And I say, show me, because that'll never happen. This is because kinetic energy changes exponentially with respect to velocity. You believers have been saying this for 350 years. Sadly, you never proved it. Well, momentum changes linearly, so we're back to that crap again. I would say the change is merely proportional. Your inability to understand this is what's causing your confusion. And I say, okay, believing in unevidenced scientific claims is worse than confusion. Yeah, and that's what they're doing. I mean, this claim that I'm confused, when, no, you're incapable of being honest. You're incapable of having any integrity at all. I've clearly pointed out the paradoxes and you just keep running from them. No explanation. You make up complete crap. I asked the simple question, okay, the 8-pound bowling ball has twice as much momentum, twice as much kinetic energy, so why can't it knock down twice as many pins? And instead of answering the question, you pretend, well, somehow nobody can throw an 8-pound ball. It loses all its velocity. It only has 1.4. You can't double its velocity with the same energy. So you come up with a complete bullshit response. Made up nonsense. All right, if you roll the 8-pound ball and it achieves twice the speed, there is no logical reason it wouldn't. So again, they will conserve momentum but have different kinetic energies. Saying isn't showing. So I'm just saying, they just keep saying it as if it's a fact, and yet they'll never show you a single shred of evidence defending it. You clearly didn't look at Table 3 in the source closely enough. I would argue you didn't look at the Professor Lewin video closely enough. Tracking the energy of projectiles traveling almost the speed of sound doesn't seem like the best kind of experiment. Why not stick to velocities easier to catch? Certainly easier to clinically examine. Yes, let's stick to things where we can actually videotape and watch and do all kinds of stuff. Too ridiculous. All right. So he says, unfortunately, I don't think I have the power to stop someone from changing their question in such a manner. You mean changing my question? I didn't change the question. Somebody else changed it. Oh well, he says. I here provide you with the earliest experiment which distinguishes energy from momentum, dropping balls into clay. So as people on this channel know, now obviously he doesn't know, I've already mocked that into the ground 7 million times. That is the worst kind of physics, right? Where you're deliberately trying to prove something, so you find a substance, you find one experiment that proves your case, and you don't show anybody all the other ones. So that's what took place in the factual history of this stupid equation, is they cheated the evidence enormously. The advocates cheated. Okay, they quote mined the evidence and they found one experiment that indicated what they wanted to prove. So just like gravity cheats your perception, that is, the light thing looks like it's more energy because it goes further, clay is doing the same thing. So it's just a way of cheating perception. It's just a way of saying, look, this ruler says, and we know the ruler is broken. The first inch is this big, the 5th inch is this big. The inches are way out of line. It's not giving you a good measure like a spring would. So, so obvious. All right, so he says, I hereby provide you with the earliest experiment. Okay, I am well aware of this 300-year-old experiment. The unresolved question is, if springs contradict these results, which they do, which experiment is to be believed? The fact that clay applies its friction disproportionately with a bias towards fast things can be scientifically understood. The consistent reliability of springs is, in contrast, well tested. Springs care not how fast you compress them with within wide tolerances. Clay, on the other hand, changes quite dramatically with slight changes in temperature. If I shoot two objects with opposite velocity to mass ratios into gravity, so now I'm giving the gravity example, your formula said one object will have twice as much energy as the other object at liftoff. So I use exactly the same force, There's two objects. One has one mass, one is two masses. Okay, and we know this one's going to go way up here and this one's going to go here. But we also know that when they land, they're going to compress the spring exactly the same amount because they have the same energy. All right. Anyway, if I let the objects fall on an identical spring, they will be recorded to impose the same pressure, the same joules of energy. So again, this guy is going to now say, oh, I caught you because pressure isn't joules. Weight isn't joules. Of course it is. It's all convertible. We already know. This is another fact of physics that physics never cleaned up. Now there's even people like Sean Carroll will point out it doesn't look very good that physics has 73 different ways to measure energy. You know, that they never really made a standard. And so they just call it watts or joules or pounds or, you know, foot pounds. They call all kinds of stuff. Kelvin, Celsius, calorie, all kinds of different ways. And that's not very good science. But anyway, then they'll sit there and argue that joule is the only way to measure energy. When, of course it's not. I can convert joules into newtons. I can convert joules into anything. Watts, pounds, I can convert it into anything. There's no obstacle. All right, anyway. I like the object. Okay, joules of energy. How do you reconcile that fact with your theory, or do you dispute the fact? Okay, so he doesn't directly answer that, unfortunately. Okay, it would be a more compelling argument if it were true. So now, instead of paying any attention to what I actually wrote, he's going to talk and pretend I said something I didn't say. So I clearly said the spring doesn't care how fast you compress it. That's what I clearly said. It's just no doubt about it. And he converted that into, I think springs compress the exact same amount for every inch, when I never made that assertion. Instead, springs also compress or stretch exponentially in proportion to spring stiffness. Yes, the spring gets stiffer, but at the same compression, it always produces the same energy. So there's no doubt about its reliability. We can understand, we can put those marks right on the spring and know exactly how much energy we're getting. The further we go in, the deeper the notches get shorter and shorter and shorter. So it's still a very good ruler because those are very accurate little notches. Okay, indicating energy rather than momentum conservation. So, more horseshit. I also dispute your fact because pressure is not measured in joules like energy is. So again, I'll be pointing out, okay, that a newton is the weight of a stick of butter. So it's a quarter pound. A newton is a quarter pound. It's a pressure, okay? And then all you're doing to make a joule is you're just dropping the quarter pound on the ground, and that dropping weight, that's a joule. Of course it's pressure. Of course it's weight. I could measure it with a scale. I could measure it. I could actually do the experiment. I can measure a joule of weight. All right. So anyway, I mean, maybe I'll end here and then come back for another edition later. It's an awful lot of blah 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 blah. All right. So yeah, that's where I left off. So I'm on the spring chart. Okay. So again, it's just always change the subject, constantly changing the subject, constantly changing the subject, constantly changing the subject. We know springs are reliable. And my point is it doesn't matter whether I go like that to a spring or whether I slowly compress the spring. It doesn't make any difference to the spring. It's just going to measure how much total pressure I was able to push the spring with. What's the maximum pressure? That's all it cares about. All right. So, I'll be back eventually. Probably. It's very discouraging, though. I mean, this is just such crap argumentation, and we just get to go through the same horse shit every time. So I'm just going to have to, I'll write another question. I guess I'll have to just be simpler and simpler. Well, could we first have agreement on the fact that 8-pound bowling balls are going twice as fast as 16-pound balls when I use the same force to throw them? I mean, can we get all the physicists to agree on that? Or are you going to pretend there's no controversy? I mean, when clearly there's physicists are physics-minded people who think it's actually possible that I can't throw the 8-pound ball twice as fast. Yeah. Anyway, so we'll call this a video and be back for more at some future point. Yeah, I haven't responded to his last comment yet, so maybe I'll do that. I mean, it's just, he's doing this summation thing. I've provided you all the links possible, and so I've explained entirely the truth, and so you're just an idiot because you don't get it. My evidence is fantastic. When there is no evidence. And just like the question poses, there's no physical experiment proving this theory. None. And if it existed, it would be already here. We'd all be going looking at it right now. Okay? All my adversaries would be showing it over and over and over again. Gary's wrong. Here's the really good experiment showing Gary's wrong. It's not happening. All right. So, till the next time and such, and so forth and whatnot. This has been a DraftScience video presentation.